Hello, friends. In this video, we're going to be talking about data, specifically different formatting of data. There's two main ones that are relevant to this video, and it's the differentiation between long and wide data, which I'll display through examples, and we'll also be going over something I mentioned in the very early video about factors as a type of variable. So I'll just show how to make a normal categorical variable into a factored variable. So because this is kind of towards the end of the lesson and course, I'm just gonna, for the sake of time, just kind of hop right into the code and have my files ready. So I put the data folder into here, but I just need to change the folder name from what I was practicing with. Okay, so this should hopefully work. First I'll run tidyverse. And then okay, so if we take a look at this data, you see that there are 5 different patients, have their age here, and then you have blood pressure readings from 4 weeks. And what you'll notice is that it's all the same type of measurement, it's all blood pressure, but the reason why it's a different column is because it was measured on another week. So in this case, where it's the same variable, but different time points, it's repeated measures. When you have data that's set up where these repeated measures are displayed in different columns, it's called wide data. And when you're working in R, especially in the tidyverse, it's much better to be in long data where you only have one column where it says blood pressure, and then here it would say week, and you'd have so this would be like one week, 2 weeks, 3 weeks, 4 weeks, and you'd have 4 readings for each patient. So this would I'll show you what it looks like when you make it long data, but it's only one column for that type of reading. And it's better in the tidyverse because when you do certain graphs, they need to be in long data, and I'll show you an example of that. So first, okay, so we're going to be pivoting. The way we do this is through a function called pivot, and you either use the function pivot longer if you're going from wide to long data, and you go to pivot wider if you're going from long to wide. So I'll just write out the structure of pivot longer. So you're going to start out with the columns, and that is going to the columns that you're gonna, this is basically saying which columns that are like wide. So like in this case, these columns are the ones that we are going to be specifying by, because we want to condense them all into one column. So the cols is going to be, and then we're going to use another function called starts with, and this function is it is able to read the characters in like a object, and in this case, it's reading the characters of the variable names. So we're going to want to, in this case, we want to come up with a character phrase that all of the columns that we want to condense contain, so that they're all included in this new column. So amongst all of them, fortunately, they all begin with BP underscore week. So we can just use starts with. So the way this function works is it will start analyzing from the beginning of the character object, and then see which columns match what we're starting with. So we're going to do BP week because that's they all start with. And then we'll do names to, and the names to column, or names to the names to column is basically going to take these blood pressures and then going to it's going to say like BP week 1, BP week. You'll see what it'll do, but it's going to be the like thing that it's going to be the new column where it says like 1, 2, 3, 4 instead of you having the columns of 1, 2, 3, 4. So you want it to be the thing that designates that it's multiple readings. So we're going to name it week because in this case, blood pressures were recorded on a weekly basis. So now that we have that, we can run the code, and now we have a blood pressure a long form of the file we had. So let's compare. So now we have, instead of just one column, run one row for each patient, we have 4 rows because they have 4 observations for each patient. And then instead of having 4 columns for blood pressure readings, we only have 1 column. And we created a new column called week, which has this number of each of the previous blood pressure columns. So now we could keep it like this, or we can kind of clean it up. So we could also, let's do, so in this case, it just says value, but we can, we want to make it a more, more descriptive column name. That's going to be our variable. So we're going to add this values to argument. So it's going to be the same thing, but we're adding this values to argument, and we're just going to name it what it actually is measuring. So this column are all blood pressure measurements. So we're just going to change to blood pressure. So now, let's see here. Okay, so now it's the same as this one, except now we gave this column a title of where the values went to. We gave it blood pressure. Now the last thing that we can do, if you want to get a little fancy, is if you don't like how this value also is BP week 1, BP week 2. If you just want to say 1, 2, like week 1, week 2, week 3, because we know it's measuring blood pressure, we can add another function that's actually like a custom function that transforms the names of these values so that it only says 1, 2, 3, 4. So I'm just gonna copy and paste the code, and you would kind of just tailor this to the code that you have. Okay, so we're basically transforming the names of this. So you know how in this argument names to what ended up happening when we did this argument, we went from these names because we basically said these things, BP week 1, BP week, BP week, BP week, are the names of just the weeks. So when we said the names too, because it moved it to this column. So we're basically transforming, we're changing the data that was sent to that column, and the function we're using is going to remove this string that starts, and it's basically saying it's removing the phrase BP week. So all of these values should lose the prefix of BP week. So now we can run this, and now we have a third data set, and it's much cleaner. Now we only have the numbers. So given that, we can I could show you why it was beneficial to do that. Let me just get rid of, I realize my filter is on, and I want to fall asleep as I'm writing this. I just want to show you why we would do that, an example. So let's say, so basically there's this type of graph called a spaghetti plot, which is a bunch of different lines. It's like a line plot, except you have more than one line because you have more than one observation or patient group that you're studying. And I'll just give an example. So let's say you wanted to see how the patient's blood pressures changed from week to week, but you wanted a different line for each patient. So the way you're going to do that is you're going to do ggplot. Data is equal to the last one we did. So, and then plus geom line. So the x-axis is going to be day, right? Sorry, it's going to be week. The y-axis is going to be the blood pressure. And then the group, which is going to, when you do add group in this case, you are basically saying telling ggplot to make a different line for each level of this group, which in this case, we're going to make the patient ID. So there's going to be a different line for each patient ID, which corresponds to a different patient. Then I'm just going to make alpha, which is a part of the aesthetics that is kind of like the thickness of a line. I'll change it to 0.4. You don't have to, just kind of depends on how much data you have. And then labs, I'm just going to add some labels. So this is time in weeks. Then we have Y is blood pressure. I don't know. I'm gonna guess just millimeters of Hg. And then let's do title is change in blood pressure over time. And then just do make the theme black and white so it doesn't have that classic car gray background. So see, so this is change, so that is this data would not have been able we would not have been able to present in if we use the wide data because it couldn't like these you couldn't say x is equal to week because uh there's no week variable and these are treated as each variable and you can't make a column like you can't make like a list of columns equal to one axis. It's just not how R works. So you need to make it a longer data set. So that's how you go from wide to long. I'll just show you how to go from long to wide. But it's not that useful. But if you ever needed wide data, this is how you do it. So so here's an example of long. So I'm just gonna use an example of long data. So Gapminder data UV underscore CSV. With data. Gapminder. So here we have long data because as you can see, there's multiple observations of life expectancy over different years and for multiple. So you have basically multiple observations of life expectancy for the same country. So if you wanted to go from wide to long, long to wide, you would use pivot wider, and you would just do paste what I have. So you do names from. So the names from, you're gonna add the column that has the kind of the interval of observation. So before it was week. So that time you had observations at every week, and this one it's every I guess 5 years. So that's going to be the one that you make names from, and values from you get from the life expectancy, which actually has the actual value of that of the life expectancy. So this should make it so that you have a column that says life expectancy year and then the year that it was. So I guess it just made it the year instead of saying life expectancy. So this is each column is just the year, and then the value is the life expectancy that year. And now you only have one row for each country. If you wanted to do the same thing, if you wanted to have your you wanted to have your columns to have that prefix, it's pretty easy. You just add another argument called name underscore prefix. And there you go. So it added best prefix to each column. So now that's it for really the pivoting. In terms of using a factor, let's see if there's any interesting data to use here. Let me just pause the video and I'll get some interesting data. Okay, so I found a data set that we could possibly use. It's the All Reliable Body Measures, CSV. So run that. And let's see, we're going to try to find a categorical variable that might make sense to change factors. This one's not as fun, but let's just do what we have. Use what we have. So the only one we have is gender. And what we'll do for that is basically what I want to explain is that whenever R will do an analysis, specifically like a regression, it will choose a baseline level for the data by, I believe, by alphabetical value, unless it's a factor variable. And this is important because let's say you're doing a regression, a statistical analysis where one of your variables is your treatment. So it was given this treatment, was not. The number you get, depending on which level is treated as a baseline, because the way that analysis works is the higher level variables are compared to a baseline. So it's like compared to, let's say your variables for given treatment are 1 and 0. That is going to compare, like when you do a regression, the number it gives you is going to say compared to a baseline, this treatment, people given this treatment have 1.5 times the likelihood of remission, like something like that. So it matters how R sees the levels of the variables, and it's important to control that. So in this case, male and female, it can be important. Traditionally, the female level has been treated as baseline. So whenever you include gender, or I guess in this case it would be sex, into a model, most of them would treat females as a baseline. So it'd be like, compared to females, men are 1.5 times likelihood to have a coronary artery disease. However, you might not want that. You might want to make male the baseline. So the way to do that is just by using the mutate function that we learned from dplyr. So let's just say factor VM, and we'll do VM, and we'll pipe it into mutate function, and we're going to make a new variable called gender, and then FAC, short for factor. And then we're going to use the function factor, and then state the variable with which we're getting the values from, which in this case is gender. So gender, and then we'll do then we need to state the levels that we want. So if we want male to be the baseline or treat it as like the lowest number, then we'll do male. Well, how is it loaded here? So it's uppercase, and then you just list it in order, in the order that you want. And then, so now we run this. See. Oh, it's because I forgot to properly write this. Okay. So yeah, so you do levels equals, and then it's going to be a list. I mean, or vector of these of the values, and you get, like I said, you're writing it from lowest to highest order. Now it should hopefully work. And now we should have those are some big columns. So this one worked. I'm a little confused as to what this what that name is. Oh. Hi. It is late in the day. It's my third video. Let's see if this fixes it. All right, that's a little promising. Yeah, there we go. Okay, so while you can't see it, there is a leveling to these now that there might not have been before. So that was it for this video. I talked about how to go from wide to long data, why it's useful to do that if you're using ggplots and making yummy spaghetti plots, and going from long to wide, as well as about factors and why you might want to change the leveling of a categorical variable, especially if you're doing a regression analysis. So this is the first video of the odds and ends. I need to figure out other things that I've missed, but if this is the last video I'm making, I hope you guys enjoyed this lecture series, and hope you found it useful and enjoy using R in the process. If this isn't the last video, then I'm going to say the exact same thing again in the next one. So I hope you guys have a great rest of your day or night, and I will see you maybe in the next one or maybe not.